Hello, you're welcome. In this video, we are going to be looking at how you can perform bitwise operations in Excel, and I'll be demonstrating this using a waste management system. So we are going to be using this as our application for this demonstration. So this waste management system is in a way that it sends sensor reports back to the headquarters, and it sends a 1 when the sensor is picking up the hydraulic arm, which picks up the waste bin. So when this is what is going on, it picks up a 1 and sends it to the headquarters. And when what is in action is the compactor, which compresses the waste inside the truck, it picks up a 2. As well as for the GPS tracker, it picks up a 3, and a warning beacon, it picks up a 4. And these reports are being sent to the headquarters. So you can use this to track what is going on, as well as make calculations to tell the customer what the customer is supposed to pay. So these are just what I want us to understand before we go into the details. So for the first thing is for the controller reading. So we can see that the controller reading is being sent to the headquarters are in decimals, and we can convert this to the binary bits. So we use the function to bin. We initially created a video on this, so you can check the playlist to see this very video. So we use this function to convert our decimal to binary, and these are the binary conversions for these decimals. First and foremost will be for the bit, and we want to demonstrate how we can get our bit and for these very controller readings. So let's say we have a controller reading of 6, and when we look at this intro sheet, we can see that a 1 being sent shows us that the hydraulic arm is currently what is working, and it picks up the waste at that point in time. So I want to see when a 6 is sent, was the hydraulic arm being used? That is what we are going to check here. Then when a 9 is being sent, was the hydraulic arm being used? Now for this very 2, which is a compactor, we want to check when a 6 is being sent, was the compactor used? For this 3, which is GPS track, we want to check when a 6 is being used, was the GPS tracker used, as well as the last one, which is this warning beacon. So we use this now to get for the 9 controller reading, 12 controller reading, and 3 controller reading, in case these are the readings being sent to the headquarters. As we know, the AND is actually used to get a true, okay, when both of our inputs are true. So that is generally what AND does for us. And let's demonstrate this by using the function BITAND. So when we select BITAND, we select this 6 first, and then a 1, then we close. Now let's use F4 here to lock the A so that we can be able to copy this through. Now, if I enter this, it's going to just return a 0 for me, which we know is a false, okay? It returns a 0, but I don't want it returning zeros for false and 1s for true for me. So what I will do is just enter a greater sign here, and then enter 0. So that when I have a 0, it returns a false. And when I have a 1, it returns true for me automatically. So and you can see it's able to return a false for me when I have a 0. And when I have a 1, it will return a true. So in our case here, where we are checking for this hydraulic arm, we can see that when a controller reading of 6 is being sent back to the headquarters, that the hydraulic arm was not being used in such an instance. Okay, let's copy this through and then see what all these will show us. So if I copy this and copy this down, I will need to change each of these. So this one I will change to 2, and this one I will change to 3. This one I will change to 4. So what this tells me is that when I'm checking for this hydraulic arm, for this first one, the hydraulic arm was not used when a 6 was being sent. But when a 9 was being sent, it was used. When a 12 was being sent, it was not used. But when a 3 was being sent, it was used. Then for this compactor, you can see that it was used when a 6 was being sent back. but it was not used when a 9 was sent back, and so on. And this is just what our BITAND will help us determine in this case. Then for our BITOR, BITXOR, if you recall from basic computing, the OR requires at least one input to be true, okay? While for the XOR, which is also known as the exclusive OR, it is true only when the inputs are different. That is, when one is true and the other is false. So in the case of this, our example, for our BITOR, when we use bit, what it's trying to show us is when we combine all on, it shows us whether the truck has that feature of on. Then when we are using the BITXOR, which is the bitwise exclusive OR, it shows only the bits when one truck was and the other wasn't. So ideally, we are now working with two trucks. So when we have two trucks in the same route, if we have two trucks in the same route, let's say in Lagos, for example, and currently in Ikeja, we have two trucks, and we want to combine the results that are being taken for these two trucks. If we combine all on bits, okay, with this bit or, it shows if either trucks had the feature of on. And then when we are using the BITXOR, what it shows us is only the bits where one truck was on and the other wasn't. And that is just it about this BITOR and BITXOR. So let's just see what our results will be when the first truck returns a 3 and then the second truck returns is 6. So I will just enter BITOR 3 and 6, then copy this. So this is the combined bit result that is being sent. And then for the BITXOR, which returns the exclusive, we select this and this as well. So when we use the BITOR, it combines all on bits for us and shows if either trucks had the feature on. And then when we use the BITXOR, it shows only the bits where one truck was on and the other wasn't. So I hope this actually clarifies what we did here. Then we go to the BITLSHIFT and BITRSHIFT. So in this case now, we are introducing another sensor. We want to make a chance for such a sensor to appear here. And in such a case, we are going to be using this BITLSHIFT, which will shift to the left, and BITRSHIFT, which will shift to the right in order to make accommodation for the new sensor that we want to use. So first of all, let's convert these our readings from decimals to binary. So we use the Decode bin to perform this. And then for our BITLSHIFT, we are going to be using these decimals. So for these decimals now, when we do the BITLSHIFT, which is moving us to the left, when you look at this binary, why I wanted us to see this binary is for this number 11, when you move towards the left, you're seeing that you're increasing the number compared to when you move towards the right. So when you're moving towards the right, it's as if you're reducing the number. So this L shift, we actually work by multiplying. It's actually multiplying compared to when we are moving to the right, which will be dividing, reducing. So what we do is just to use the BITLSHIFT here and select this reading and the shift amount. Let me just move it to 1. I want to just move to 1 position, and you can see it actually moves this to 6. And then if I want to use the R shift, in this case now it's going to divide it so that we have a lower value than this 3 that we have here. So I use BITRSHIFT, select my number, and then shift amount to be 1. And you can see that this is 1, this is 3, this is 4, and this is 6, showing us that there has been a reduction. Here there has been an increase. And these are just what I want to show us in this video when it concerns the bitwise operations in Excel and how we perform these operations. I hope you've been able to find this video helpful. Please, if you have, kindly like, share, and subscribe to our channel. Thank you, and I'll see you in the next one.